Greetings, campers, and welcome to the 7th media computation video. Today we're going to talk a little bit more about loops, conditional, but not computing. Oh my god, that's wrong. Alright, we'll just keep going. So, last time we talked about the black and white picture, trying to make a picture into just black and white. And I told you to think about that. And if you thought about it, you'd think that one way to do this problem is to take the intensity that we found for the grayscale algorithm, right? Because we took the red, green, and blue components of a picture and we added them together and took their average divided by 3. And that became the intensity, and we took that as the value of each of the color components for the grayscale. And that worked out pretty well. But instead of doing that, what we could do is, well, we could do that computation for each pixel, but then we could create a boundary value in the middle of the range. The range is 0 to 255. And if the intensity is less than the boundary, that means the color is darker on average, then we make that pixel black. And if the intensity is larger than the boundary, then we make the pixel white. And that way we'll end up with a pretty good representation of the photograph, but only in 2 colors, black and white. So how does that sound? That sounds pretty good. So now, in order to do that, we'll need to make a decision. So just to give you a quick 30-second if statement refresher, remember that if statements are used to make decisions. They're also called selection statements in certain places. The result of the expression in the condition of an if statement must be a Boolean, and because that's how the condition decides what to do. If statements can certainly be nested within each other. And if statements can either just make one decision or they can have an else clause, which is usually read as otherwise, and that clause will get executed if the condition fails. And so, we can have, there we are, in Java, we can have a conditional an if statement that has a condition and a single block of statements. Or we can have an if statement with a condition and just a single statement, although usually this is safer so that you can put stuff in the middle if you want to change what the block of statements is. Or you can have an if statement with a block of statements for the then condition, and for the otherwise or else condition you can have a separate block of statements. Or, as we saw in the flag maker example, we can have a series of nested if-then-elses. So if condition number 1 is true, we'll do this. Otherwise, if condition number 2 is true, we'll do this. Otherwise, if condition number 3 is true, we'll do this. And you can keep going on and on and on. And then the very last one just has a final, if nothing else is true, then do this. So we won't need to do that now, but that's something that you should remember from the flag maker exercise. All right, so now we're ready to write the black and white code. So if we look here, here's a version of it. I have this class called picture black and white. In my main, oops, I need to change this back. We're going to call black and white. And I have a black and white method that we're going to call. Let me move things out here so we can see everything. There we are. And here's what my black and white method does. It takes as input a picture, and it takes as input a boundary. And that's so that we can change the boundary, so we could move the where black and white change to a different place in the range. We grab all of the pixels in the picture. We'll iterate through every pixel in the picture. we grab the red, green, and blue components of each pixel, we compute the average, and then we say if the average is less than the boundary value, then we'll set the color of the pixel to black. Otherwise, if it's not less than the boundary, it must be greater than or equal to the boundary, and if that's the case, we will set the color to white. And that's pretty much all she wrote. So we're going to call black and white with this picture, and we're going to set the boundary smack in the middle at 128. So let's see how this works. And we'll go to main, and we'll pick a picture. And I've got a picture down here of swans on a lake, which work out pretty well if I can find the swans. There's the swans. There's the swans on a lake, and bam! Just black and white, which gives you high contrast. Now it hides a lot of the details because all of those features in the picture that were in sort of the middling range of colors are going to get washed out because they'll either be completely black or completely white. But you can still pretty much see the swans in here, although they are a little bit washed out themselves. But it gives you nice, interesting, contrasty stuff. Let's do another example. And we'll go to this, and we'll find another picture to play with. There's green turtles, Greek ruins, fish, dog, swans. How about the red motor? Oh, wait, shops. There we are. We have this long list of shops, and they get bam to black and white, and it looks actually really pretty good because you notice that the lighter colors, the greenish and the reddish ones, all got turned to white, and the rest of them get turned to black. So it gives you a very interesting thing. There's one other thing that we could do. Do I mention it here? Yeah. So the question we can then run into is how about generalizing the black and white program a little bit? And we'll come down to here. And so what this does is this just changes the color based on a single boundary. What if we add a second boundary so that we would convert the program into a picture with 3 different colors? And so we'd have 2 boundaries, a low boundary and a medium boundary. And here's what this one would look like. I've done it a little bit differently just to give you a better idea of how we can do things. In this case, I declare all of my variables beforehand before I use them. So there's this big piece up here where it's nothing but variable declarations. And you can see that our signature for slide colors takes the picture and then the low and the medium boundaries. And then in the for loop, instead of doing just the an array of pixels, we'll look at the picture as being a rectangle, and we'll do all of the columns, and then for each column we'll do each row in that column. We'll grab a pixel at a particular location, an XY location. We'll get the red, green, and the blue values of that pixel. We will compute the average, just the way we did before, except now that we have 2, and I'm going to change this back to red. Oh no, actually this would be green, I think. Green, red, and blue. So instead of having a single if statement, we have 2 nested inside each other. And so if the average is below the low boundary value, we're going to set the color to green. Otherwise, if the average is bigger than the low but less than the medium, we'll set the color to red. And if it's bigger than the medium, then we'll set the color to blue. And that's pretty much it. This gives you an interesting effect. Let's try it. Let's go back and try it on the swans again and see what we do here. Oops, didn't kill the Java virtual machine. Okay, let's try that here. And we'll go here and back to media sources, and we'll try the swans again just to show you what it looks like. Here's the swans, and 1, 2, bam! Now 3 different colors, red, green, and blue, depending upon the values that were in the picture. The blues are the darkest, and the greens are the lightest, so this is the side of the hill and the nice side of the water, and then the reds are the intermediate values. So that looks pretty good. So you could, of course, do it for 4 colors or 5 colors or 6 colors or 7 colors or 8 colors, or as many colors as you like. But this is just another way of showing you what kinds of effects you can get from doing these kinds of things. All right, let's continue. So we looked at a rectangle here a minute ago. Let's formalize that a little bit. All right. So the pixels in a picture are really stored in a 2-dimensional structure. Each pixel has an x value, which is typically a horizontal location, and a y value, which is typically a vertical location. And we use the getPixel method to grab a pixel at a particular location. Examples of 2-dimensional arrays, maps that you see if you've ever seen a road map or an atlas map, where there was along the bottom there were numbers, and along the side there were letters, and you could say this street is in the square D5 on that map. If you've ever played the game of Battleship, you'll know what a rectangle is and a 2-dimensional array is, because that's how you tell your opponent where you want your hits to be. And then chairs at a theater or a baseball stadium are also organized as a 2-dimensional array. So row C, seat 20, that kind of thing. So there's lots of practical examples. Any kind of table that you ever used is a 2D array. So nested loop refresher. And we just saw this, how you would get all the pictures in a picture using their x and y values. And we have to have one loop inside the other. The outer loop will count y from 0 to the height, so we'll do the rows. And the inner loop would count x from 0 to the width, and we would do the columns within a row. And we can also do it the other way. Here's a template for having a nested loop that goes through a rectangle, and this is in particular for a picture rectangle. In this case, we would be looping through the rows first, so the outer for loop, did it the wrong way again, didn't I? Okay. So the outer for loop is going to go from 0 through the height of the picture, so it's going to take one row at a time. The inner loop is going to go from 0 through the width of the picture, and so it will do one row, all the columns in one of these rows. You'll get a pixel and the XY coordinate frame. You will do something to the color in the pixel, and then you set the new color to whatever it was you wanted it to be. To do it the other way, you just flip the X and the Y for loops, so that you do the x's first. This will do all of the columns in the picture, and this will do all of the rows in one column. And once again, you get the pixel, and you do something to the color, and then you reset it. So it works quite nicely. Now, why are we going to use this? We're going to use this to do another effect, and that is to create a mirrored effect in a picture. There's 2 different ways to do this. You can place the mirror here, horizontally, and so the top half will then mirror down onto the bottom half, or vice versa. Or you can place the mirror vertically between the pictures, and the left half will be mirrored in the right half. So it's just like you looking in a mirror, and it's just like you placing a mirror flat on a edge down on a piece of paper or something on a desk. So we're going to be able to do that. So now, how does this work? Well, the idea is, say this is my picture, and these are pixel values that I have in my original picture. Okay. What I want to do is I want to loop through all the rows. So I want to go row, 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 and then loop with X starting at 0 and go through all of the columns, but only halfway. In this case, I'll stop here. And then what you do is you get the pixel on the left-hand side, and you get the pixel on the right-hand side, which is the matching pixel. And that matching pixel is actually at width -1 minus X. So the first one will be at width -1 because X is 0. And the next one will be at width -2, and then etc. And then the last thing you do is you set the color for the right-hand pixel to be the same as the color for the left-hand pixel. And that's how we copy colors. So once we've done this, whoops, I want to go back. Once we've done this, our picture will now look like this. Because this picture has an odd number of columns, the middle column stays the same. It's invariant. But the other two columns, this column on the left stays the same, but this column on the right now mirrors that outer column on the left. And this column, second column here, is mirrored in this second from the right column over here. And this whole half of the picture gets blown away. Okay? But what you have is you have two mirrored images of each other in the picture. Okay? So changing it to code, the first thing we need to do is we need to get the midpoint. And since we're assuming that the mirror is vertical on the picture, we have to use the width, and we just get the width of the picture and divide by 2, and that's the midpoint. Because we're going to do integer division, if it's odd or if it's even, we still get to the right place. Then we loop through the y values, so we're going to go down each row, and then we're going to loop through the x values, but starting at 0, but only to the midpoint. Okay, and then we grab the pixel from the left-hand side, which is what this would be, and we grab the pixel from the right-hand side, and the pixel from the right-hand side is the width of the picture -1 minus x, and it has the same y component. And then we grab the color from the left pixel, and we make that the color of the right pixel by using a set color method. And what this will do is it'll create a mirror of the picture, as if the mirror were vertically through the picture in the middle. In fact, let's stop right here and go see this. Okay. So here's my picture mirror class, and we're going to execute the mirror vertical. We grab a picture, we show the picture, we call the method, we wait a couple of seconds, and then we repaint. Here's the mirror vertical method, which is just exactly what we talked about. We get the width, which is going to be the width of the picture. The mirror point is the midpoint. We divide by the width by 2, and then we have left and right pixels that we'll declare. And then the loop starts and does all the rows. So we go from 0 to height -1, and then for each row it does half of the columns. So it goes from 0 up to the midpoint. We grab the left pixel, we grab the right pixel, we get the color from the left pixel, and that becomes the color of the right pixel. And that's it. That's all you have to do mirroring. So let's take a look at this. And I need to find an interesting picture to, oh, I know a great picture to mirror. Oh, I didn't reset the Java virtual machine last time. Thunk, there we are. I do know a great picture to mirror. The coolest thing about mirroring these pictures is the way things turn out. And so just for the fun, we'll make me mirrored. Down the middle, thunk. I now have just turned into a cyclops. Kinda, sorta. And you notice that here the mirror is right down there. So it's, I think this is an extremely amusing way to do it. Let's do another picture down the middle. And we'll take Dropbox. Thunk, thunk. We'll go here. And let's, let's do, there's a motorcycle up here somewhere. Let's do the red motorcycle. There's the red motorcycle. 1, 2, boink. Mirrored down the middle, just as if we had a mirror. Here, this would be a motorcycle that goes both ways or not at all. All right. So now, the next thing to do is turn the mirror around, and instead of having the mirror vertically on the picture, have it horizontally on the picture in the middle. So this is like a reflection of a mountain that you would see in a mountain lake, or a reflection of a car standing in a showroom. Okay. So how does this algorithm work? Well, it works just exactly like the vertical mirroring algorithm, except, of course, it is in the middle. And this is actually what the result would be. So we would start here at the top, and this row would become the bottom row. The middle row would become the middle row down here, and this row would become this row here. And this one works out nicely because there are an even number of rows. Once again, if there were an odd number of rows, then the middle row would be invariant. The algorithm is the same. We'll come back to this in a second. And so here's the horizontal line. In this case, though, in this one we were doing width everywhere. In this case, we're doing height. And so here's the method to do mirror horizontal. We grab the height. The mirror point is half the height. And then we, instead of having a left and right pixel, we have a top and a bottom pixel. We now, instead of going through all the rows, we go through all the columns first. And so we go from 0 up through get width minus 1. And then we go through all of the rows in that column. Actually, we go halfway through the rows in that column. We grab the top pixel. We grab the bottom pixel. It's the same equation. It's height minus 1 minus y. And then we get the color of the top pixel and we set it to the color of the bottom pixel. Nice little nested loop that will get us through every pixel in the picture. Now let's save this one, and we'll do mirror horizontal called pick. That was what I called it, wasn't it? Yes. Okay. And we'll compile it. And we'll take a look at it. And we'll pick a picture. Let's see, who can we turn upside down? Let's do Professor Brightboard. Who used to be Dean. There he goes, and then there he goes. So you have sort of a Santa Claus effect there. And now all the top pixels, you can even see sort of the line where it goes. So it works out pretty well. Let's do one more. And let's see, what do we have? What's a good one? Gray motorcycle. Go. Dunk, dunk, dunk. 2 seconds later, my motorcycles got both sides up. So you can even do combinations of them. You could even decide, instead of doing all of the rows, you could do half of the rows and half of the columns. That would get you 1/4 of the picture that you would map onto another quarter of the picture. You could do, now what we did was we did an exercise where we mapped to the top half of the picture onto the bottom half, and that's what that is. But what about this question? What about going the other way, mirroring the bottom to the top? How would you do that? And I will leave that as an exercise for the interested reader. And we're done for now. And so we'll see you later when we're getting ready to do MediaComp number 8.